Good morning and good afternoon, and welcome to this conversation on edge computing. This is part of a report by Senza Fili that is published in collaboration with FierceWireless. And today I'm talking to Neeraj Patel. He's the Vice President and General Manager of MobilityEngine at Radisys. Neeraj, thanks for being with us today.
Thank you, Monica. Morning. Thanks for having us.
Well, it's always a pleasure talking to you, and this is a good opportunity to catch up with what you are doing on edge computing. Can you give us a bit of introduction, especially for the new listeners out there?
Sure. So I think most of the people will be familiar with Radisys. Radisys is a key player in the emerging space for mobility edge compute. Just a quick background, Radisys, we have solutions for wireless access on the RAN space, all the way from the old 2G days. Believe it or not, there is still some 2G deployed, 3G, LTE, LTE Advanced, and upcoming areas with 5G new radio, 5G NR. We look at RAN as a critical component where Radisys plays in, and then obviously as we get into the core network, the edge is becoming more and more important. That's where a lot of the action is now being pushed towards at the access, and MEC, or mobility edge compute, or now multi-access edge compute as Etsy calls it. That's a critical component where we are still continuing with our building block approach. And we'll get into details of what we mean by a building block approach, but effectively there are different components that we provide. There is different areas of expertise that we help our customers with. Different operator engagements that we are being pulled into, and would love to talk a little bit more in detail about how we really enable solutions for MEC.
Now let's step back a little bit, because you've been working on edge computing for a long time now. So can you tell us how is your solutions and your view of the market or the challenges you're trying to address changed through the last few years?
Yeah, so if you recall, and I think a lot of the industry veterans will recall, there was something called LIPA and SIPTO in the 3G days, effectively local breakout. So Radisys, obviously, we had developed solutions for LIPA and SIPTO. I don't want to cannibalize MEC by calling it yet just another extension of that, but one of the initial use cases that we've been involved with, in fact, I just came from Australia and talking to one of their leading tier 1 operators there. We demonstrated a local breakout gateway on the ONF MCORD sort of platform last year. That was very well received. That, I would say, was sort of the first starting points for MEC as far as Radisys goes. Again, content delivery networks, CDN, that's another key area that we've been working with. There are obviously industry leaders such as Akamai in this space. We've been working with them for, how do we bring in CDN for such networks? And then there are myriads of use cases. Most recently at MWC in Barcelona, we did a demo of an AR, VR application. Again, for us, we look at it as an application in a simplistic form, as a VM that we initiate, onboard, orchestrate on our platform, on our NFI platform. And that obviously has a specific MEC use case. What's changed in the last year, 18 months, 24 months maybe, is with 5G coming in, and even if you look at LTE Advanced, the latency requirements are getting more and more critical. Usually a healthy debate is, where is the edge? A lot of folks have different definitions depending on which operator or which MEC solution provider you talk with. They all define the edge to be different. And I've picked up so many new words like near edge, far edge, close edge, things that I didn't know existed. And now when you look at the network, you go like, oh, okay, this is depending on where you put the MEC box. Are you intercepting at the S1? Are you intercepting at GI LAN? What is the use case that's driving it? That really is becoming key. And I think that the third one, and this was again validated by discussions, I literally got off the plane an hour back, coming in from Australia, and spoke to all the leading operators there. And one common case that came up is enterprise private networks, industrial IoT, and one common building block there that they all mentioned in different conversations, maybe at different times, but consistently was, we need a solution for doing something at the edge. We need a MEC solution. And that obviously then leads to questions around, hey, what is our wireless RAN access coming in? And then obviously, you know, what is our core? But we need this box sort of sitting in between, and we need to offload the traffic. We need to come up with a box that can actually be the broker, so as to say, for these industrial IoT use cases where AR, VR, or any video application basically has to now be sort of set up on. So that's one thing that we are seeing has a key difference is all these different latency requirements that are kicking in and where the box is placed.
So do we have an answer as to where the box should be?
I think we have a good idea. The answers definitely lie with the operators and definitely lies with the use case. But obviously, from our perspective, where we are seeing MEC fitting in beautifully is right at just behind the base station, sometimes co-located with the base station, depending on, again, the latency requirements. There are some use cases where we have seen it sitting in the core, but typically most of the engagements that we've been involved in conversations or where we are working with different customers on is where it is either co-located with the base station or just behind. That's where we are seeing it. And behind meaning going towards the core network.
No, right, absolutely. Now, what do you see your role within the ecosystem of edge computing to be?
So Radisys obviously is an enabling solution provider. Where we see ourselves coming in is we want to provide all the different building blocks that help our customers. It could be ODMs, it could be OEMs, and it could be CSPs, the commercial service providers, help with their MEC strategy. Our philosophy of MEC is the different building blocks that we have literally allow a Lego building block approach where customers will have their own assets that they've developed, meaning that some customers have their own Mano infrastructure that they want to bring in. Some customers, almost all the ones that we are speaking to right now, have some form of their own NFVI architecture in place. So they want to look at us as, hey, Radisys, can you come in and help plug in, taking, for example, the Intel NEV, the network edge virtualization function. Can you take this, enhance it? Yes, add the RAN access to it through the RNS APIs, add in the traffic management portion to it, have it bolted or plumbed onto our NFVI architecture, obviously talking through the Vim layer. It has to all be now orchestrated. It all has to fit into our overall OSS BSS strategy. And most importantly, enable these different VMs. We meaning our customers, and we ourselves work with a host of different application VM guys. They could be guys who are doing AR apps, VR applications, what have you, have that plumbed onto this common infrastructure. So where Radisys comes in is to provide this end-to-end software solution integration around this sort of different MEC building blocks. And that's where we see ourselves coming in. The other area where our customers are coming and talking to us also is, hey, Radisys, if you're going to be co-located with a base station, what else can you provide me from a base station solution perspective as well? And as you recall, Radisys obviously plays a very key role for eNode Bs and then obviously the GNBs. And then taking that and extending that into a co-located MEC, that's another area where customers are talking to us for.
Now, you mentioned private networks, and that's clearly there's a huge amount of interest there, but also brings the enterprise in as a party that in public networks is not really there. So it makes things more interesting, but also more complex. Can you tell us what is the engagement and what are the reasons for the enterprise to need edge computing in the first place?
So private networks is definitely gaining a lot of steam. The service providers are looking as private enterprises. Obviously, these are high ARPU customers. So definitely there's a lot of interest from a service provider perspective to go serve the enterprise. It's a key component of their customer base. Think of oil rigs, mines, hospitals, stadiums, what have you. A couple of things from a technical perspective come up. concepts of neutral host, concepts of doing IoT, network slicing, and that's where MEC really fits in well. Customers are looking at the MEC box as something where they could provision a lot of the services for their enterprise without having to dip into the expensive core resources. And for a lot of these enterprises, they have obviously the connection to the core, but a lot of the network is very local, so as to say, within the enterprise. And that's where the MEC box actually works as the perfect broker, sort of helping to segregate the local traffic from the traffic that actually has to go out into the core. So a lot of the mobility and all the mobility management all can push out to the core, the standard stuff. But there's a lot of IoT traffic, static IoT traffic coming in, and het nets, and managing and provisioning those, the local CDN stuff, AR, VR applications for industrial IoT, what have you, depending on the enterprise class. That's where they are looking at the MEC box has the perfect sort of solution on which they can provision a lot of these services on. So that's where we are seeing a lot of interest coming in.
Yeah, this is clearly a key area of interest. Now, you mentioned network slicing as well. And oftentimes the two go together, edge computing and slicing. How do you get them to work together?
So there is obviously some level of DPI, deep packet inspection, that'll happen. There'll be assignment of flows. So the typical network slicing model where you do it through the resource blocks on the base station. You'll do an end-to-end slice that'll cover slice from the base station all the way down to the core. A perfect area, or one of the areas I should say, where you can actually put the network slicing function will be on the MEC box as well. So one of the key building blocks that we provide is what we call our flow engine product. We have a virtualized flow engine. Think of that as DPI, doing 5-tuple inspection, packet filtering, traffic coming in, segregating the IoT flows. These have very limited requirements for session management, mobility management. You're not using the expensive core resources doing that. So this IoT traffic that is now being put back into your network or being put onto a separate network. One of the areas we spoke about is potentially using a LTE network as a bit of an overlay. You have a 5G network that you're deploying, but you're using your existing LTE network almost as an overlay for your IoT traffic. I don't really need to use my expensive 5G network resources for some of this IoT traffic. I already have this network available. The MEC box actually helps you broker that. Even if you look at from a core perspective, a EPC, a stateless EPC to do IoT traffic handling is a much, much lighter version than a full-fledged EPC or going forward, the 5G core network, the 5G CN. So these are the areas where we see IoT and hence network slicing being a function to enable that, sitting with MEC. And I think you nailed it. I mean, we look at network slicing and MEC as really, it's almost in the same vein. We talk about it differently, where the function is actually implemented is on that MEC box, is how we look at it.
Right, and it makes perfect sense. Now, another use case that people talk about is connected cars for MEC. But there you have the issue of mobility, because cars move around, and as you push stuff to the edge, it's distributed, and the cars are moving. So do you see that to be an important use case for MEC, and if so, how can you address it?
Yeah, so connected cars is very, very interesting. In a simplistic view, our opinion of a connected car is it's basically yet another UE. It's another user equipment. If you look at the amount of information that cars have today and what people are talking about it will have, with all of this V2X technology that's going on, it is going to become a very, very smart smartphone, the car itself. Two areas there. One is street side cabinets, because there's so much of data being exchanged. And more importantly, the latency requirements are so stringent. I would say that besides remote surgery, when that actually becomes something that becomes a real use case, connected car, I would recommend, or I would imagine, has the most stringent requirements for latency with the amount of data that is being exchanged, especially for the driverless cars. For the other aspects of where you're pushing data back into the core network, again, the MEC box, be it a street cabinet, be it something on a light pole, I don't know what the implementation of it will be in terms of the deployment model, but it is going to be something that is curbside. That's where MEC becomes important. Again, MEC will handle all of the mobility management aspects. If you look at MEC, it does have, the RAN is coming in inside the MEC network. So that's where you would handle a lot of these cases, and then you're brokering it off into the core. You would also have a lightweight core that's actually co-located in the MEC itself. So a lot of those functions of the S gateway, the P gateway, the MME would actually be also co-resident in the MEC box itself. There are numerous companies that basically are taking the EPC or a CN and bringing that into MEC. And that's really why you are now talking about a network in a box as far as MEC goes for these use cases. The other thing that we are seeing a lot of is also when you talk about these firmware updates, FOTA, firmware updates on the air. So today, your car is nothing but a souped up computer that gets a lot of firmware updates. If you give your car in service, one of the normal things besides oil change is getting the software updated all the time. So the idea is now, how do you push all of this FOTA stuff, the firmware updates on the air, which is nothing but now looking like a CDN network. And you're going to suck up a lot of bandwidth if you're doing it through the core. So a lot of these MEC boxes are now going to have, within a certain area, they will now actually push the FOTA to those registered cars. So that's where we are seeing a different use case coming in, is for the MEC to also be your local CDN sort of repository, so as to say. The third use case that we've seen is parking lots. In fact, every parking lot is becoming more and more of almost like a smart city in its own self. With the amount of information that we exchange from keyless entry to managing and knowing which car is pulled in when, which car pulls out later, CDR sort of things, to actually also the FOTA that can be done when the car is parked there, having different use cases. And there are a lot more intelligent, creative people out there who will be writing different use cases. But parking lots are going to become really smart. And those are going to be nothing but you'll have a MEC box sitting in that parking lot.
Right now, another party that is interested in edge computing is are the application developers and over-the-top providers, the content provider. How do you see them fit into this new sort of the edge computing ecosystem? Who are they going to be talking to? Who are they going to be working with? Are you working with them? Is the operators working with them? Are they going to pay for it?
So we are actually working with a few of the OTT guys. Some of them are pretty well known in the industry. So they are using the operator network as the delivery pipeline, but they are the ones who are actually putting a lot of the intelligent content on top of it. It could be, video being pushed out. So again, high level CDN, but is it video being pushed out? Is it doing some level of authentication, what have you, for some specific application? So that's where they're using the MEC box. They're talking to us for, hey, Radisys, can you come in and do the plumbing? Give us, maybe they have selected a MEC solution provider. There are a few upstart companies in this area, but there are holes there. And that's where Radisys really comes in as a software solution integrator, saying we understand the core, we understand the RAN, we understand the delivery network coming in, we know the equipment boxes, we've deployed equipment boxes. How do we now sit and fill up some of the gaps, plumb in the specific applications or VMs that these OTT guys have, which are going to be specific to the application that they're pushing in. A lot of these OTT guys are also building on their own networks today. So if you talk to the guys like Netflix or Amazon, they are building out their own little mini data centers and data centers as you get into the core. And a lot of these will have MEC boxes sitting there with their local content that they're pushing out for targeted audiences. Obviously, we are getting involved with players such as these guys in terms of how do we help them with building that network piece of the network out, bridging, the existing solutions and making them compatible, and sort of how do they fit into their network. That's where we play a part in, and we expect to keep playing a part as this keeps evolving.
And this is interesting because as these guys, the content providers come in, and the distinction between wireless and wireline networks is going to tend to disappear, and you're going to see much more of a convergence. Do you see that happening?
Absolutely. So it is multi-access. The reason for it being called multi-access edge compute is you have broadband and wireless coming in. In fact, we work a lot with Cord. So one of the things that we've done in Cord, for example, for broadband access, is that we've also now worked onto a box called Volta. It's actually an abstraction layer. So you have different OLTs, ONUs that operators can bring in. The reason I bring that up is that for us, Volta is one model, not necessarily the only way, but broadband access coming in. It could be a CPE device, a Wi-Fi device, an OLT, ONU coming in, some sort of broadband access that, again, is getting terminated onto the MEC box before it goes into the core. So that's where, again, from a MEC perspective, one of the building blocks for us, in addition to the wireless LAN access, is broadband access.
Now, you mentioned Cord and other initiatives. At the beginning, ETSI-MEC was edge computing, was the same. But now edge computing, it's becoming much more in wireless. It's more than MEC. Can you say how the different initiatives are important and how do they work, either work with each other or compete with each other?
So just to spend a minute on ETSI-MEC. So we, over the last, the heritage that Radisys has is always being standard compliance. Always follow standards of 3GPP, IETF, you name it. ETSI, obviously, ANSI standards. So with MEC and ETSI particularly taking a lead role in defining the MEC standards, for us, that is perfect. That's exactly the model that we want to evolve towards. So for us, working on the MP1, MP2, all the different interfaces that ETSI is specifying, that is our MEC strategy. Going back to your original question about the different organizations, the trade groups. So active members of obviously Cord, active members of TIP. TIP has a working group for MEC. We are members of that. For us, following these different industry consortiums, and if you look at them, these are driven by operators. There are key equipment manufacturers who are in these different consortiums. So sort of being part of that community is critical to Radisys. Hearing what people want to deploy, and these are the forums where this is actually brought up. A lot of these use cases are being actively discussed in these different forums. So for us, following it, being a part of it is critical for us. I mean, it's I would say a cornerstone of our strategy, and compliance to standards and hearing what happens in these different consortiums and how do we sort of bridge it between what they're discussing versus what the standards are saying. Invariably, they're pretty similar, but obviously there are subtle differences that happen, as you are aware of. So making sure that all of this keeps sort of flowing in the right direction, that's critical to us. Radisys does not believe in putting out a proprietary MEC solution or a proprietary MEC box. We want to have building blocks that are in line with standard compliance that ETSI is putting out, in line with what we're hearing at TIP, how the core platform will evolve as it gets towards the edge, going towards MEC. Being part of the different vRAN alliances that are formed up, because all of this eventually does call out a MEC box. And that's where we see ourselves playing a part of.
Now, you mentioned MEC boxes, so that sort of brings to mind the issue of the business case. You're adding some infrastructure out there with that computing. And so how can you justify the business case for it?
Sorry, can you repeat that question? Justify the business case?
How can you justify the business case for edge computing where, from at some level, you have to add some infrastructure? So it's a cost element. So where is the business case coming from?
So the business case comes in from your OpEx savings on the bandwidth, on the OpEx savings because of you're not using your expensive core resources. All operators are facing, they're increasing capacity coverage, but at the same time, spectral efficiency, bandwidth efficiency is number one for them. The second is just the fact that there isn't a technical way otherwise to solve the latency issue unless you move the core closer. So you're not going to move the entire core closer. That doesn't scale. And that's where multi-access edge, basically it is a layered hierarchical model that's coming into the networks, that it makes sense to do that. The third element here again is a function of what are the applications I enable, and hence what is the ARPU that I'll eventually drive. So if someone wants to see a video downloaded on their mobile, tablet, PC, what have you, and if that's going to be buffered or choppy, and if that's going to cost money to the operator to transpose those bits from a data center sitting 100 kilometers or 100 miles away, I think that itself causes MEC to become very important. So it is that localization of that content, the ability to deliver that content in meeting those latency requirements, meeting the performance and the optimizations that are needed for that performance, and end of the day, the user experience. I mean, all of this, if you look at why did 4G evolve and now why is 5G evolving and why are we talking about, gigabits of download and upload, it's all about the user experience. That's where we see MEC coming in.
Yeah, and then certainly there is a lot of value in improving the user experience and the efficiency of the network. So that's clearly very important. Now, this is all great, very interesting. We've been looking at the past and at the present. What is, in closing, what is it you're working on in the future? What is it you see the big challenges for edge computing that we need to address in the future?
So one of the challenges, and not to be tongue-in-cheek, is definition of MEC differs from who you talk to. Getting more and more alignment on where exactly MEC will sit, what MEC really means. We don't want to lose the creativity in it, but at the same point, it would be interesting to get more alignment, broad industry alignment around what exactly, where it fits in, how does it fit, what are all the different elements in it. Faster standardization. There's a lot of work that SC's already done. How will different RANs, for example, come in? MEC is not going to be a greenfield deployment where there is a brand new RAN, a brand new core, and a brand new MEC box. It's going to fit into existing networks. So the ability for multi-vendors to be able to play in this market, the ability for multi-vendor RAN to come in, multi-vendor EPCs, the core, the 5G CN to come in, and the quicker bolting of 5G into this. I think that's really where we are hoping, and that's where immense opportunities exist. That's what keeps all of us excited in this field. We'll all talk about this in the upcoming shows, but that's really where we would like to see the industry evolving towards.
Mm-hmm. Well, Neeraj, thanks so much for being with us today.
Thank you, Monica.
And thank you all for listening in. This was a conversation with Neeraj Patel at Radisys, and it's part of a report on edge computing by Senza Fili. Thank you very much for listening in and watching.